Build and run elastic, agile, and resilient apps with Akka. Trusted by industry titans and disruptors, Akka ensures your applications stay responsive when it matters most. With a simple SDK, powerful libraries, and flexible deployment options, Akka has you covered. Learn more at akka.io.
Welcome to the Architects Podcast, where we discuss what it means to be an architect and how architects actually do their job. Today's guest is Randy Shoup, who has spent more than 3 decades building distributed systems and high-performing teams. He started his architectural journey at Oracle and as an architect and tech lead in the 1990s, then served as chief architect at Tumbleweed Communications. He joined eBay in 2004 and was a distinguished architect there until 2011, working mainly on eBay's real-time search engine. After that, he shifted into engineering management and worked as a senior engineering leader at Google and Stitch Fix. He crossed the architecture and leadership streams in 2020 when he returned to eBay as chief architect and VP for eBay's platform engineering group. He's currently senior vice president of engineering at Thrive Market, an organic online grocery in the U.S. It's great to have you here on the podcast. And I would like to start out by asking you, were you trained as an architect? How did you become an architect? It's not something you decided one morning and you woke up and said, today I'm going to be an architect.
Great. Well, thanks for having me on the podcast, Michael. I've listened to so many of the, in general, InfoQ podcasts, and particularly your interviews with Bernd and Lizzie and various other ones. So super excited to be here. Yeah. How did I become an architect? Yeah. I woke up one day and said, today I will architect. No, my background is multidisciplinary. So when I went into university, I was not expecting to be a software engineer. I always loved math and computer science, but I was planning to be an international lawyer. When I was in college, it was the late 1980s. I graduated in 1990. So it was the height of the Cold War, and the US and the Soviet Union had tens of thousands of nuclear weapons pointed at each other. And I wanted to stop that. Anyway, so long story short, through my university career, I studied political science and particular focus in international relations and East-West relations. And from that, I took an appreciation of nuance and seeing the big picture and really understanding the problem writ whole. I won't go through all the boring details, but I also, while I was in college, interned at Intel as a software engineer. So like I worked building software tools for Intel's mask shop, which is one of the things that you need to do to, make chips. And I loved that. So when I graduated from university, I was planning on being an international lawyer. That was the mainline career. And I ended up double majoring in the political science and then mathematical and computational science. So then I was like, well, I'm not going to go straight to grad school. So I worked for 2 years as a software engineer at Oracle. Then I was like, okay, time to, take the GRE and the LSAT and go to law school and international relations school, which I did start. For reasons that didn't work out, I wasn't as interested in that as I thought I would be. And the secondary career side gig of software was really pretty fun. And so
in other words, don't quit your night job.
Exactly. Yeah. Well, very well said. Yeah. If you have a side gig that you love more than your main gig, maybe you can make it your main gig. And so that's kind of what I did. So alighting over lots of details, which we could talk about or not, I wasn't excited about the international law career for reasons, and then begged for my job back at Oracle. My friend and mentor and manager at the time welcomed me back with open arms. And so it's really the combination then of, the engineering skills and doing software, with the typing and also being able to see the big picture. And so to me, I think we'll talk about this, is a good architect is somebody who can go all the way up and all the way down. And Gregor Hoppe, whom I hope everybody who's listening to this knows, has this wonderful phrase that's in his books called the architect elevator. So like from the boardroom, so you can talk to executives, all the way down to the engine room where you can actually tweak the machinery. So how did I become an architect? It was crossing those two things. I always was a techie and a fuzzy, as we used to say in college. So both on the technical side, really enjoyed the math and the science, and also on the other side, fuzzy, so like liberal arts and so on.
And lo and behold, here you are. So one of the things that we've talked about, and I know both of us are interested in, is realizing how fragile our critical systems are. And very often the engineers, and which is surprising, and the public, which is not as surprising, does not realize it and realize the consequences of the fact that these systems are fragile. I mean, the most recent one was the example of the CrowdStrike failure. But even things such as, let me pick an example that people are probably most familiar with. You go to Amazon, you're told that there are 3 books left, but you actually have to wait till you get later on in the process to find out you're actually getting the book.
Right.
And even if they tell you get the book, what happens when in the process of getting you the book, it gets damaged in the warehouse in the process of sending to you? Do they cancel? They ask you, do you want it? So the interaction between the software and the messy world is something that I don't think people understand.
Yeah. And like the real world can be messy, as you just, said, like, okay, physical goods can be damaged in warehouses. They could not make it in shipping. They could get rain damage. They could not be there, even though the system says they are. And also, even more often, the software can screw up, right? Like the software thinks that we decremented, software forgot to decrement a counter when they should have, because reasons and all sorts of stuff. People can't see me because this is a podcast, but I do not have hair, but once I did. And so I like to joke that, when I entered software and then architecture in particular, I did have hair. That's actually a true statement. And yeah, I mean, with all the failures and trying to deal with them and trying to design around them, right? Like that's in large part how my hair, how I went bald.
Well, I think you just said something very, very important that a lot of people don't think about. And I've gotten pushback from people when I used to talk about this. I used to have a whole talk about designing for failure.
Yeah.
People didn't like it. Well, some people did appreciate it, of course. I mean, I'm not saying nobody liked it, but especially if you got to the higher ups, they didn't like it because why should we think about failure?
Yeah.
We want to design for success. And
Michael, you're designing for failure to start. Like, what are you doing?
Right. But I think we see this also in software engineers. And this is in security. This is in lots of places. They like to design for the happy path.
Yeah.
They think this will work and this will work. Yeah. And when it comes to an error, okay, we'll just throw an exception without thinking about where the exception goes, what the program state is.
Yeah.
To be caught by the great exception handler in the sky. So how do we get developers and the business leaders and the public at large to understand that software failure actually is a fact of life?
Yeah. In your question, you already went boardroom to engine room, which I love. So let's start with the boardroom and then drop to the engine room, right? So how do you have this conversation with executives? And look, if you look at talks I've given, like sections in them, even if not entire names of talks, are all about designing for failure and everything fails, which is absolutely true. How does one have that conversation with executives? Is just making it clear that this is not about, I want it to fail. This is about things go wrong in the world and we have to deal with them. And so the designing in face of failure, it's not designing in order for it to fail. You were never saying that, but it's designing for it to be resilient, right? So, I mean, that's the term of art these days, is resilient in the face of failures. So there are lots of ways to do that. But having that conversation is, look, as architects, we should be able to say, must be able to say, hey, we get the happy path. There are many things can go wrong along the way. And here is the way that the system is going to handle when those things go wrong. And that could be the system retries things. That's legit. That could be the system times out. That's legit. That could be the system reconciles, comes back around, like in banking, right? Like you send things back and forth between banks in real time, but then there's this reconciliation at the end of the day, at least traditionally, where you looked at the 999,000 on the one side and the 1 million on the other side, and you sorted it out with rules or with humans. So in all these situations, the architect needs to imagine, I guess I'm in the engine room already. The architect needs to imagine all the things that can go wrong. And what I think trips up a lot of engineers is it's scary to think of, well, gosh, so many things could go wrong. And that's true. So many detailed things can go wrong. But if you think about it from a higher level, there are usually not a million different classes of failure. There are a million different like instances of failure, right, along the way. But even a relatively complicated workflow, like, I don't know, a payment system or a checkout or something like that, there are a handful of classes of things that can go wrong, right? Resources could be unavailable. How do we deal with that? Logic could not work. How do we deal with that? Things could be slow or down. How could we deal with that, right? So like what trips up people that are new to this, which is fine. People are beginners. I'm beginners in lots of things in my life. But the beginner is that it feels overwhelming. Like there's a million things that go wrong. How could I check for all of them? And the answer is don't. The answer is think about the 3 or 4 classes of things that can go wrong and have a pattern of how to deal with those individual things.
In other words, think about the system state, thinking about what the safe point is, where you go back to. I mean, to give maybe a concrete example is there's lots of reasons why the credit card service you use may not be available, but you only care about the fact that the credit card service is not available.
Beautifully said. Exactly right. Yes, I'm going through my checkout flow and I want to charge the payment method and I can't. And we can imagine, if we thought about it, 25 different reasons together off the top of our heads in a minute why that could be true. Network down, my payment system is down, their payment system is down, my credit card, blah, 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 blah. But from the perspective of the logic of that thing, it only matters that I cannot charge this payment method at this time. So the wonderful thing about working with credit card systems is they've been around for a million years and they're clunky, but the interface does tell you what happened. So you can get something back that says, oh, the card was declined in a like unrecoverable way, like this is a fraudulent card. Like, okay, we're not going to retry that one. Or the more common case is it's some kind of transient failure. And like, all right, we just retry it. Or if a human's there, we could say, hey, human, we couldn't charge this method. Want to give us another card? As every single person listening to this has had the experience in buying something at the grocery store or whatever. And for whatever stupid reason, their particular card in the moment isn't getting taken. So, hey, do you have another one? Like, okay, sure. We can ask that, again, patterns to deal with this are exception handle all the way up, to the top of the system, which in this case, if someone's there as a human, or pop it up and then retry that part of the workflow, right? Retry the charging the payment method like step. There's lots of ways to deal with it.
Also, there's very often a business rule that enters in.
Yeah.
So, for example, if the credit card service is not available, and this is a customer that you know very well, and it's $5 or $1,000, whatever is small in your business, you may say, go ahead.
Yeah. Yeah. And actually, I'm sure you know this, but not everybody listening might. This is exactly how ATM machines work.
Yes, that was the exact thing that popped into my mind when you said that.
Yeah. And again, just to say, either of us could say it, but I'll start saying it. The way ATM machines work is, hey, they have network connectivity to the office systems of your bank, just like anything else. And they have rules in there that say, if you cannot connect to that person, you feel free to give Randy $20, but do not give him $2,000, right? That kind of thing.
And also, this is a situation where, because you may be on a network that's not your bank's, there has to be reconciliation among all the banks at some point in time, which is what you made reference to before.
Right.
So it's a combination of business rules and software judgment.
Yeah, I'm going to riff off that in 2 ways. I really love the way you said it. So again, to restate, a million individual instances of things could go wrong. There are typically a small number of classes of failure. For each of those classes of failure, we may have a business rule that says, hey, this is how payments are supposed to work. When this kind of failure happens, you're supposed to retry for 3 days and then you can give up or whatever, right? So to your point, there could be, in an ideal situation, a business rule that says what to do. In any case, we have to solve it, regardless of whether there's a business rule that told us how to solve it. We as engineers have to solve it. Like that problem will occur and we need to decide what to do. We can't throw up our hands. And so again, we should apply some kind of pattern to that. The other thing that when you mention business rules, I really love and I want to reinforce for people, we're talking about a payment workflow or a checkout workflow, but this is a generic comment I'm about to make. The initial instinct of the naive engineer, and I've been naive for more time than I should admit, is to hide that failure. And better is to have it be part of the interface. Like, again, if you've not worked with payment systems or checkout systems, the interface is not, please make the payment, yes, no. It is, please start this payment. And there's a workflow with states behind it. And those states are visible outside, right? So it's visible to say, hey, the payment is started, it's pending, it's completed, it's authorized, it's completed. And my point there is, as an architect or a software engineer dealing with one of these domains, oftentimes when you have these failures, or when it's possible to have these failures and you can't resolve them immediately, as in this example, pop that up a level. Like, that's now part of your interface. Part of the workflow and part of the payment system that we just sketched is the idea that payments can be in this intermediate transient state. They can be accepted, but not yet already done. And in the US, for those of us who, live here, we still have to wait 3 days for if we're gonna pay Michael for something. Like, typically it's, the banks give themselves 3 days to get everything all sorted, even in the modern world.
Just as an amusing side point, I remember the days when I ran a business that took credit card payments.
Yep.
But this was before real computerization. You'd have a stack of credit card slips, the one the merchant had, and you go call the bank and list off all the numbers, and they would tell you, in other words,
right,
whether it was good or bad. So in other words, part of the problem is that I think a lot of people have never worked with these manual systems and realize that actually the probability of failure is higher than people think. People very often think it's not going to happen. I'm sure you've heard engineers say that. We don't have to worry about that.
Yeah. The wonderful and terrible thing of working at places like eBay and Google is the things that occur 1 in a million times occur thousands of times a day.
Because you have 10 million times.
Yeah. And the things that occur even 1 billion times a day at Google scale occur thousands of times a day. So there's no hiding. And you didn't really ask me to do this, but I'm going to say it anyway. It is not professional software to ignore failure. You are not being a professional. You know this, and I know you believe it, but just for the listeners, like, you are not being a professional software engineer if you don't handle, in some way, failures. And handle could be, again, retry or reconcile or something automatic, or it can be simply fail all the way up. But one way or another, you can't ignore, I was going to say the possibility, the guarantee. I guarantee you that everything in your system will fail at one point or another. Guaranteed. Absolutely guaranteed.
Yes. And you have to leave the system, however you handle a failure, in a stable state.
Correct. And I know you and I have chatted about this, so maybe this is going to make me want to take it in like a transactional way. So a way that we traditionally have approached this problem, and it's a good one, it's a great tool to have in our toolbox, is transactions. So, the conceptual idea, I know everybody knows, but like the conceptual idea is, I have several things I want to do, and let's wrap them all in a transaction and make them all happen together or none at all, right? So atomic, consistent, isolated, and durable, the ACID properties. And when you have a system where that can work, it implies a single database. When you have a system that can work, that's great. That's a wonderful tool in your toolbox you absolutely should use. And also for the systems, even the quote simple systems that we were just talking about, payment systems, checkout, et cetera, not like that. There's not a single database between Bank of America and Deutsche Bank when they exchange stuff. There's not a single database or a single, distributed transaction between my local grocery store and the credit card processor. So how do we deal with that? It's asynchronous. And so we make it a workflow. And, workflows are made up of asynchronous messages, and we figure things out. And we have the saga pattern, which we could talk about in detail if we're interested. But the conceptual model at the higher level is, well, when I can't make it a transaction where it's all or nothing in this moment, I need to then think about it as a workflow or a state machine. And it's incumbent on me as the software engineer to make sure that we enter that state machine, from a safe system state, and that we transition through the states in that state machine, and we exit the state machine in a safe state. And again, what I was saying before about like making these transient states visible, like when you're in one of these situations, it really behooves you to not hide the fact that there's all these state transitions and transient stuff happening. Instead, that should be explicitly part of the external interface, if that makes any sense.
I think I can give you a simple example of that where it should be visible not only to the system, but to the end user. Let's say you're signing up a customer.
Yep.
And they have to provide social security number, all kinds of information.
Right.
They may not have all the information at once.
Of course.
So what are you going to do? Throw them out and make them re-enter everything all over again? Or
Right.
keep it in a semi-complete state, which may enable them to do certain things,
Right.
but
Right.
not other things.
Right. What a wonderful, visceral, evocative metaphor. I mean, that's gorgeous, right? Because like everybody can say, well, yeah, when I'm getting my passport, as my son just did, like there are steps and there's a whole workflow. And like he doesn't have his birth certificate and all these things like all at the same exact moment and like transactionally enter them all and not. And even if he did, to your exact point, he spent 2 hours entering all this various, biographical information about himself and various things and proving his identity and so on. And if at the end, some stupid thing at the U.S. government,
Internet goes down,
and he had to go re-enter all those 2 hours again, like that would have been insane. I mean, it was annoying enough as it is. So anyway, I love that metaphor because it doesn't mean it's a fail. I mean, like a workflow is resilient to failures. A well-defined workflow is exactly resilient to the kinds of failures we're talking about, and also it is resilient in quotes. There's probably a better way to say it. To, you know what, I don't have that information right now, right? So like thinking about filling out a government form or doing a payment process or even the software engineering that we do, thinking about it as a workflow is really freeing and it is the problem. One of the other, like, it's a meta principle for me, and I mean, this is the way I look at it, but I think the very best architected and designed systems I've ever worked with are like very directly aligned with the problem. This is exactly domain-driven design, but like when you can take your overall problem and reify the real world into the software like directly, if that makes any sense. Like there's a thing that's part of the world. We have, eBay. Like, okay, people buy and sell things online. Okay, well, just imagine what happens when you're buying and selling things offline. Every one of the steps that you do, like I walk into the store, I go choose the thing, I pull out my wallet, like all the steps that happen do have an exact analog in the software system that we build. And if we can use the inspiration and the often thousands of years worth of like human knowledge about how to do those things in the real world and just put those into the software essentially, then we're in much better shape. The example I always give in this is I never worked for, Lyft or Uber or Grab or whatever, and I don't know their history, but I should look it up. I guarantee though, because this is how every system evolves, they started as a monolith, each of them, I bet. And then what's the natural domain decomposition for an Uber? It's driver side, rider side, right? So like the rider side has a bunch of concerns, and apps and so on. And then totally separately from that, there's the driver side. And then totally separate from that, there's the back office, like, well, how do you show the rider what drivers are available, blah, blah, blah. So like where I'm going with that idea is it behooves us as architects to really fully understand the real problem. Like what's the real thing we're trying to do? And in this case, it's obvious. Like, okay, I want to get a ride from point A to point B and somebody's got to drive me. And then reify that or express that in the software. And then to the point back that we were talking about how to deal with failure, it becomes pretty obvious what the patterns are. Like we have to still type and stuff, but like it becomes pretty obvious what the like patterns or conceptual mechanisms, if that makes any sense, to deal with these things. Like what's supposed to happen when, I schedule a ride and they don't show. Well, like, because they're late or whatever. Like, well, I don't know. When you're hailing a cab in New York City, how does that work? Well, okay. It's exactly the same thing.
Although some things become a little more difficult in the virtual world. For example, go back to your eBay example. If the merchandise is right in front of me, I can inspect it.
Yeah.
That's a more complicated problem in the virtual world. Or to go to your example of Uber and Lyft, in the past, there was a taxi commission that I knew sort of the police ran a security check on the drivers.
Right.
So in other words, how, as you say, with the reification, sometimes it's not a one-to-one mapping.
Totally. So we are strongly agreeing, but it won't seem like that for one moment. Yes, the conceptual problems are the same. Like, hey, I want to see if this merchandise I want to buy is good. That is a real problem. To your exact point, the solution in the virtual world is different from this. Like, I can't touch and feel it. So what else can we do? And you weren't asking, but I'll actually tell because it's cool. eBay has at least 3 mechanisms I can think off the top of my head for that. Number one, eBay's feedback system, that's been around for the 28 years or whatever of eBay. And this is gameable, but you can develop over time a trust system for the seller and for the buyer. Okay, so that's number one. Number two, in terms of the specific merchandise, there's for various things, I think it might be broader now than when I was there before, there's like a money back guarantee. Like if you get something and it doesn't meet the description, there's a mechanism to return it and get your money back. And also for particular items that are very often counterfeit. So think sneakers, watches, handbags. So a bunch of these things, particularly for like Gen Z, are like traded assets, essentially. Like people get I'm going to say it wrong, but like people get the Michael Jordan, like super sneaker or whatever. And it's like only made 10 of them. They got gold stars on them or whatever. Anyway, so for that, eBay has started actually bringing those things to physical warehouses and physically inspecting them and putting like a virtual like stamp of approval, if that makes any sense. So long-winded way of saying 100% there is that same problem statement, which is, hey, I want to buy this thing. Is it good quality? And is it the thing that I actually want to buy? And in the virtual world where we can't touch it, we actually need to do a bunch of different other schemes, essentially.
But if you think about it, and I'm going to date myself a little bit here, this is the exact problem that Sears Roebuck and Montgomery Ward had with mail order.
Totally.
So in other words, there was a reputation in the company there as opposed to the person. But again, there are more analogies than one might imagine to help you think about this problem.
Yeah, that's great. I love it. Yeah, exactly. Mail order. Yeah.
I have found that people have trouble with workflow and state machines.
Yeah.
Especially where there's approvals involved and there's long running. Before when we were talking about state machines, we're talking about in a program where there's failure. It may be asynchronous, but more or less the software is waiting on itself, so to speak.
Sure. Uh-huh.
But when you have things like getting approvals, which is another way where workflow comes in, when it's long running, people have trouble with that, especially when you have to do with choreography or event-driven stuff. That becomes another level of abstraction that you have to put on things.
Yeah, 100%. In fact, I'm dealing with this exact issue in my day job because, hey, we're an online grocery and we take people's payments and we need to ship them things, and that's a workflow. So the most widely known, well-functioning pattern for this is called the saga. Anybody wants to Google with that, they'll find stuff from Chris Richardson and Katie McCaffrey on what are called sagas. And so just very high level, we got this workflow and lots of different, not one system does it all. Like it's interactions between different systems. So A sends a message to B does some things, B sends a message that's received by C, they do some things. And the saga is just a way of representing that at a bit of a higher level. And then if there's a failure at C or D, then you do compensating operations. So you do individually transactional, individually durable operations along the way, but they're separated in time, right? So A happens, and then at a totally different time outside that transaction, B thing happens, and totally after that, the C thing happens. And if there's anything that goes wrong with this workflow, you do what's called compensating operations, essentially undos, in the reverse direction. So there's a lot of literature and techniques around that saga pattern. That's a great one for people to, why did people even invent that? And exactly because this is hard. Relatedly, though, and this is something that I'm just looking into, but lots of people know a lot about, is an open source system called Temporal. It is a way of making these workflows durable in a very easy to program setup. And I'm not going to do it justice because I haven't actually done this stuff yet, but we're going to do it real soon now. So you mentioned choreography. So there's choreography versus orchestration, right? Choreography is these events fire and traverse themselves, but there's no central coordinator. Orchestration is where, just like in a conductor in an orchestra, there's a central, in quotes, controller that makes sure that A and B and C and D happen or don't happen and like controls the workflow going back and forth. So temporal is a orchestrator concept, and you program that orchestration logic in a regular programming language, Python, Java, PHP, whatever. They support Go, they support a million of them. And the system stores where you are in that workflow. And if you have failures along the way, it brings the system back to the state where you were, and then you just keep going. I'm not giving it full justice, but actually, if anybody Googles for temporal, they have a great website with lots of sample code and lots of great explanations. And also, there are literally 100 or more YouTube videos about how it works and all the companies that use it. And so I won't even be able to list them all, but like every Snap story is a temporal workflow. At Coinbase, every Coinbase transaction where you're moving crypto back and forth is a temporal workflow. Netflix uses it as the base of Spinnaker, which is their CID/CD system. I'm actually forgetting a bunch of things, but it's used Stripe. Every Stripe transaction, which is also money, is also a temporal workflow. So it's open source, and then there's a cloud offering by the company that supports it. Anyway, so I mention this only because I have this exact workflow problem in my day job, and I wanted to make it easier. And I was all set to teach everybody about what I was just saying. Event-driven systems and sagas and compensating operations and state machines and so on. And those are the real thing. Like they actually work that way. Like that's actually how the systems ultimately work at the base. But I was searching for a way to make it easier. And I think that temporal is it. And don't trust me, trust Stripe and Coinbase. And
Of course, people sometimes have trouble deciding when to use choreography and when to use orchestration.
Yeah.
But as you say, you really have to think about what's important in the
Yeah.
problem that you're going to solve.
I have my own answer because, again, as a reminder for people who, if these are new to you, choreography is like a dance where there are lots of events that are happening, but there's no central coordinator that is saying you step here, you step there. Whereas by contrast, again, orchestration is the orchestra conductor tap, tap, tap on the lectern or whatever you call it, and getting everybody to play in rhythm. So when to use the both? If this workflow is like very important and is complicated, then you want orchestration for sure, right? So payment processing, checkout, all these things that we're talking about, those, in my view, absolutely should be orchestrations. Why? Because you have a state machine that you need to make sure executes durably, reliably, and completes successfully one way or another, either all done or all the way back to the beginning. You use choreography in those cases where you don't, I don't want to say don't care, but you don't care as much. It's not as much of a state machine as an informing of other systems to do a thing. And you're like, what do you mean, Randy? Well, I'll give you an example. So I've been at eBay twice. eBay's been using an internally built Kafka-like system for many years, almost 20 years. And a thing we learned, everybody else learned at the same time too, is choreography is best in those cases where you kind of don't have a state machine, you just want to inform people and have them do stuff. So example is when you list an item on the site, we absolutely want to make sure that all the payment and the exchange of stuff like actually happens. So that stuff is orchestrated. But like when you list an item on the site, there are literally tens of different other things that happen. So you list a new item, eBay takes the image that you gave them and thumbnails it, right? And all these different things. It gets checked for fraud. It increments and decrements a bunch of counters about the seller's account. Right now, the seller has sold 1,000 things and yay, they now get a gold star, a platinum star, right? So like all these different things. And none of those is like a workflow in the sense that we could and should continue the mainline work of accepting that item and putting it on the site as those other things happen in parallel.
Because if no one gets the gold star, nothing else is dependent on that gold star.
Yeah. And I want to be clear that ultimately you do get the gold star, but like it doesn't have to happen in a state machine-y way.
Yes.
Like there's some reconciliation. I mean, this example, I think, is a reconciliation that if we didn't process that event, like every so often we come around and go, how many things did you actually sell? And anyway, but I hope that explanation makes sense.
Yeah. So I want to summarize sort of this part by sort of saying, and maybe this is something that will appeal to both business people and engineers.
Yep.
We talked about how designing for failure is a reification or an abstraction or an implementation of what happens in the real world. Well, if you think about the real world, failure happens. And the point is, you dust yourself off when you have a failure and you get up and go on.
Yeah.
So the real issue is not, did you fail? But how do you respond to that failure?
Yeah, it's exactly about the resilience to failure. The wonderful framing, which is not mine, I think it's John Allspaw's and the whole resilience movement, but I'm going to say what these acronyms mean in a second. It's not about minimizing MTBF, it's about minimizing MTTR. So what do I mean? MTBF is mean time between failures. And so if you're a hardware manufacturer, a thing you want to say is, hey, these hard drives that I ship, they don't fail very often. And you're like, what do you mean by very often? Like, well, our mean time between failures is, 1 in a million, whatever, or, 4 years for this Seagate hard drive or whatever. But that's not the right way to think about software. It's not work so hard to never have anything go wrong, because that doesn't work. Things are going to go wrong. Instead, MTTR, mean time to restore. So instead, think about when things fail, how can we recover as quickly as possible and get us back into a correct state? Again, whether that is retrying and trying to move forward or rolling back or undoing or whatever and trying to get us back to the beginning, either way. The correct thing, and we've learned this over time in the industry in the last, let's call it decade, is better systems are easier to build, much more reliable to operate, and much cheaper if you don't try to avoid failure, but instead you try to respond to failure and be resilient to it. So this is exactly the insight behind cloud computing. It's not have one big system that never, ever, ever goes down. That's mainframe era thinking. Instead, it is there are in a modern data center literally 100,000 machines and not try to make none of them fail, because at any given moment, handfuls, maybe hundreds, are down. Thousands, maybe. But whatever. Who cares? Because we put stuff in 3 different places and we can move things around quickly. And, so all these patterns at the higher level are all around letting individual components or individual steps fail. And we don't care about that because we have a higher level correctness that we've layered on.
I think last QCon San Francisco, there was a session that we both attended. It was about security, and I apologize for not remembering the speaker's name, but they had this metaphor of it's not about building a castle with moats around it and alligators and a drawbridge to make sure no one gets in.
Right.
That's not the right metaphor, because the invaders will get in.
Yeah.
What do you do to section them off and
Right.
deal with the failures that inevitably happen because the castle will be breached?
Yeah, exactly. It's not the hard shell and the soft center. It's instead zero trust, where you componentize and isolate all the individual things. You assume you're overrun. Right? Your invaders are there. They're in the house. But what can we do to make sure the room I'm in is safe? Or even if they get in the room, they can't harm me because I'm wearing an Iron Man suit or whatever. So that mental model is great. The other equivalent, and I don't know, I hope it's equivalent, is the componentization, like you say, the isolation. So that's circuit breakers, that's bulkheading, that's all those kind of patterns. And, thanks to Michael Nygaard for writing those all up in his fantastic book, Release It. Please try and read that.
I recommend everybody read that.
So Michael Nygaard and Release It popularized, because he wouldn't even himself say he invented these things, but popularized circuit breakers, bulkheading, et cetera, which are exactly this kind of isolated components that are of the system that are safe. But the other way to think about it is every mitigation or defense that we would put in place is Swiss cheese. But make sure that the holes in the layers of Swiss cheese don't overlap. I'm making this up, but imagine 5 pieces of Swiss cheese and you orient them in such a way that at least one of those things blocks everything. So there's no hole all the way through. And also probably related to the first, but I would say it separately, the zero trust, where your mental model is you're out there naked on the internet and you need to make sure that anybody you interact with is legit. So that's mutual TLS. So end-to-end encryption in transit. That's encryption at rest. That's integrity of the messages. That's authentication and authorization of the identities of the people that are talking to you.
All the things that the WS Star things tried to solve, that was a big industry struggle. But I think eventually the industry has realized that these things are important, and it's not just about encrypting or one transaction between the user and the system.
Yeah.
I do want to sort of ask you a question. I don't know if we've ever discussed this before, but this is something that's become interest to me, is how architecture can affect team performance and team satisfaction with their job. You must have come across this. I mean, at one level, it seems simple. For example, if you have a loosely coupled system, it makes it easier for individual teams to do their jobs. But I think there's something deeper here. And I think because you've been both an architect and an engineering management, and you have lots of different roles, you must have some sort of unique perspective on this.
Yeah, I don't know if it's unique, but I definitely have a perspective. Off the top of my head, I would say at least two, and it's going to grow in a moment. So number one is at the highest level, if your system architecture matches the problem, again, this is back what we were saying before. If you take a domain-driven design approach and you can find a place in your system that matches a part of the real problem you're trying to solve, that's already good. Why is that good? Because it reduces the cognitive load for the people trying to solve problems. Again, because it matches the problem. So if you understand the problem, where does the payment processing step belong? Oh, it's in the payment processor. Okay, cool. That's awesome. So matching the problem is number one. Number two is, to your point, componentization, whether that is think about as microservices or components in some other way, not having to think about the entire system all at once, but instead only having to think about the payment processor part or the bank interchange part or whatever, taking a big problem, which is the entire thing of eBay or Google or whatever, and instead making it a much smaller problem. And then thirdly, architecture should be a tool that helps you think. And so having the tools and the patterns to do things easily. And so we were talking a bunch of those things hey, if it's easy to do workflows, workflows are complicated, but if we in our architecture make it easy to do them because we have either built a system that makes it easy or we have other implementations of the Saga pattern or whatever that you can go look at, right? So a good architecture is one where as an architect or as an engineer, I have a lot of different tools. I don't mean compilers, right? I mean components in the system or patterns in the system that allow me to do things, right? Because what the best architectures that people have worked in are ones where you're oh, let's see, I need a data store. Okay, here's this menu. Okay, cool. I'll take that one. I need to do events back and forth. Okay, I'll take that, and having all those tools. And now I'm going to add a third one, which is a paved path, like at Netflix or at Google, where all the pieces of this system are well supported. So I can easily spin up a new service because there's this template. Everything's in there. It's integrated into the monitoring system, integrated into the RPC mechanism, integrated into CI/CD, blah, blah, blah.
When you're talking about tools, one thing that always comes to mind is this struggle between the desire to impose that everyone uses the same tools because it makes it easier to transfer for systems or hire people, and each team choosing the tool that's most appropriate for them. And this extends to languages, to higher level tools. How do you feel about that?
Yeah, I feel very strongly about that. You want to have both. So the best places that I have worked and the most effective, call it architectures or engineering organizations or whatever, are ones where there is a paved path or a very small number of them. Netflix and Google are great examples. Of the possible programming languages in the world, at least when I was at Google 10 years ago, there was good support for 4. There was good support for C++, Java, Python, and Go. Other languages are allowed, but you have to roll your own everything. It has to integrate with the monitoring system. It has to integrate with the testing frameworks, blah, 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 blah. So certainly at large scale, I'm going to make a different comment when you're small scale, but at large scale, having a paved path that is well supported by people whose job it is to support it. That was my team's job at eBay, by the way, support the frameworks, and also allow people to go off the reservation, right? So paved path, but you can bushwhack. And why do you allow bushwhacking? It's because sometimes the right thing to do to solve this particular problem, like some machine learning problem, let's say, they should do it in Python. like, cause that's the language where everything's written in, and if you're doing some other kind of system, maybe that's Erlang, right? So like, there's a reason why WhatsApp was only 8 people when they were acquired by Facebook or whatever, because like Erlang very matched, and that whole system super naturally matches the messaging problem they're trying to solve. Anyway, my point is, again, paved path plus the ability to do new things. And the do new things, again, is because it allows people to match the exact problem they're trying to solve, individual teams, and also it allows growth and evolution of the common framework, right? So if you're in this monoculture and you never look outside, you're stuck. Right. And there are lots of examples out in the world where companies have gotten themselves stuck into a rut where like, okay, we're only Java and like, we're going to keep our blinders on and never look anywhere else. And that hasn't been a super bad choice, but there are companies that are in the Microsoft ecosystem, which is better now than it was 10 years ago. But you know what I mean? Like, hey, we only do Microsoft. And like, even the thinking about like how to do distributed systems was like very isolated, if that makes any sense. So
yes, I lived in that world for a long time.
No shade on either of those ecosystems. I use them both, but you see where I'm going with that. So I have a strong visceral belief that you shouldn't have a monoculture at scale. Okay, now when you're small, like I am, we have 100 people in the engineering organization at Thrive Market where I work. We really should all be working on one thing. Some individual teams, need to, again, machine learning is a great example. Like they need to do stuff in Python, whether or not we did that elsewhere on the site. But when you're small, it should definitely not be like every team for itself because you don't have a lot of time to waste, a lot of resources to waste on doing things in multiple ways. So that's my quick thinking on standardization versus letting 1,000 flowers bloom.
I like that approach because it differentiates between the small to the large, and you can see what happens if you adopt what you say for small teams when you grow to larger scale. Because a lot of the problems, which we didn't talk about, and it's another whole thing we could talk about because we don't have the time. And this podcast could be hours.
Yeah, we'll do another one or something if you want.
Right. Because what happens when all of a sudden you wake up and you were at small scale?
Yeah.
And tomorrow you got mentioned in the press and you now are at large scale all of a sudden.
Yeah. Every company that we think of as large scale had that scaling event.
Yes.
It is rare to have had that happen very slowly. It happens, but it is rare. What is way more likely is everything's an S curve, but the way more likely is you're kind of chugging along, no one knows about you, and all of a sudden, kaboom, you hit something, right? Again, mentioned in the Wall Street Journal, or reach a critical mass of people knowing about it and telling their friends or whatever. And we don't have time to talk about it here, but I have thought about for many years these phases of companies and products, and like there's a starting phase and sort of a growth phase where, the J curve, as people talk about, or really the S curve, starts to get steeper and you go faster, and then it sort of flattens out.
So maybe some other podcast will talk about scaling and whatever else comes up.
Sure.
This is the point where I like to go off and ask the questionnaires I like to ask all my architects. I find it also adds sort of a human dimension to the podcast.
Great.
So what is your favorite part of being an architect?
I mentioned it earlier, actually. It's the Gregor Hoppe's architect elevator. So I get a lot of enjoyment out of going up to the boardroom and down to the engine room. Like there's something that's just very energizing for me about being able to see things and help solve problems in the large, but also see things and solve problems in the small. And each of those lenses informs the other. What I don't like.
Right. And what is your least favorite part of being an architect?
I haven't had this experience a lot, but when it is not considered important or strategic to the organization or the company, right? I don't like being not productive or useful or valuable. So if I am in a situation where it's not considered valuable, like to do this stuff, like I should go somewhere else.
Is there anything creatively, spiritually, or emotionally satisfying about architecture, being an architect?
Yeah, I mean, this is where, again, I said I'm kind of a multidisciplinary person at my core. I'm not just interested in the computer science side. I'm not just interested in the international side. We contain multitudes. And so the thing that I love about being an architect is being able to play, again, that both sides. the thing that really resonates with me is I tend to be more of a deductive reasoner rather than inductive. So what does that mean? Deductive is like you have a set of principles and you apply them. And I think more people, my sense is more people are inductive, where you look at a bunch of examples and then derive from there. I like to do both, but my go-to model is to have a model, if that makes any sense. Like I like to think in terms of, people see this if we look at my talks back almost 20 years. Like I like to state, here are the principles. We should split things up. We should be asynchronous. We should deal with failure, right? So like I like to take those principles and have a clear, almost like Platonic statement about what the principles are, and then apply them in the real world. And then maybe orthogonally to that, I didn't have this word when I was younger, but like I've always kind of tried to be a system thinker. I get enjoyment and value and, I don't know, spiritual energy, I guess, from like really seeing the whole board and then being able to do interesting things within that.
Sort of thinking about what you said, and I've done a lot of teaching, and what I found is certainly what you say is true, that most people proceed from the concrete to the abstract rather than the abstract to the concrete.
Right.
But I think there's a difference between giving a talk, as you mentioned, and teaching, where you want to start from the principles, as opposed to learning, where you want to start with the concrete example, because very often the abstract principles seem too vague.
Yeah.
Because presumably when you give your talk, you state the principles, but then you explain them with concrete examples.
Yeah. You're not implying this, but I want to say there's nothing wrong with either model. I use both. And so it's not like, oh, you can only be an architect if you do deductive reasoning and think in principles first. I'm just saying, like, you asked a great question, which is what resonates with you, Randy, at a deeper level about architecture. And that's what resonates with me, is this idea of coming with principles and then applying them. So that's what resonates with me personally. If you only did that, you would not be a very effective architect. If you only did the other way, if you only did inductive reasoning, where you only looked at examples and then abstracted from there, you would not be very effective. Both techniques are important, and I use them both all the time.
So what turns you off about architecture or being an architect?
When an architect behaves in an ivory tower way. Again, lots of people get excited about lots of different things, and that's great. Again, it's great that we have, a diversity of people and approaches in this world. I do not like not being useful. And when I say useful, I mean like a lot of us do. I have the skill and capability to like pontificate. I could do that. I don't want to. So I would much rather, again, boardroom to engine room. Like I would much rather work it so that things actually matter. Like I'm not interested in producing documents for documents' sake. I'm interested in changing the world, or at least the company, right?
Sort of in a science fiction world, you'd like to step into the UML diagram, into the box, and see what's in the box.
Yeah. And the purpose of diagramming, and the purpose of saying things and principles, and the purpose of doing architecture at all is to solve customer and business problems. Like that's what we're here for. And it is worse. You're not implying otherwise. It is worse than useless for some fancy, well-paid person to like pontificate about stuff and not have that like very directly be connected to solving a business problem we couldn't before, solving a customer problem we couldn't before.
Do you have any favorite technologies?
I do. I mean, very much obviously going to date myself. So again, as I mentioned, no hiding. Like I started my career, graduated in 1990, started doing my internships a couple of years before that. I've always loved SQL. My starting thing was doing Oracle database related stuff, again, in my internship at Intel for a couple of years. And then I went to work for Oracle for 7 years. So nothing about Oracle database in particular, although it's always been really good. But SQL, I think it's just, we have yet in the data world, and this is not a bad thing, we are still using 1970s relational algebra, whether we know it or not, in doing data systems. So I think that's wonderful. Again, dating myself in terms of when I was last, and it was a while ago, hands-on keyboard as my primary job, but I'm really good at Java and C++, so did a bunch of stuff there. not so much technologies, but, again, patterns and approaches, like particularly at large scale, and don't do it if you don't need it, but like a services or microservices approach, event-driven architecture, like those are things that really solve real problems and I use all the time.
What about architecture do you love?
I love finding an elegant solution to a problem. Actually, we just had this the other day. It would be too long to explain the details, not that they're secret, but like just the other day, one of my teams at Thrive was kind of going down a path that would work, but wouldn't be right. And so going in and doing a little bit of Socratic method of, okay, let's restate the customer problem, which in this case, hey, what does the ML team need to be able to run their models in real time? And like, okay, let's explain what you need. What is the interface? What do you have and what do you want back? I'm like, okay, now that we know that, hey, let's think about what the interface should be on the next level down. And like, okay, we have a bunch of options, but like this one is more natural. And anyway, so I love being able to see a problem and helping to reframe it in a way that makes it easier and maybe sometimes even obvious to solve. It's like such a leverage point, right? It's such a force multiplier to be able to, not by myself, but like help us all to see, we think this feels hard. We're going down this thing, we're bushwhacking, but there's actually a really easy or straightforward or like natural way of approaching this problem if only we think about it differently. And so that's what I get a lot of enjoyment out of.
So conversely, what about architecture do you hate?
I don't like deferred gratification. So I like it when, if we're going to like really put an architect hat on and like do a big architect-y thing, whatever that even means, and we can do this, but like I want to make sure that we get value now, as opposed to, hey, I sketched out this fancy architecture. Oh yeah, we'll action on that in 2 years because it'll take us all this time to do X and Y and Z. And like, so the deferred gratification there. And then similarly for quote, big changes, again, hate's too strong a term, but like a thing that is hard is dealing with what I'll call the activation energy to like get the organization to think in a new way, start doing it in a new way. Yeah. I wouldn't say I hate it, but like, if I can reframe it, like, what do I struggle with and not enjoy? Yes. That's it. Yeah.
So what profession other than being an architect would you like to attempt?
Yeah, I think I already hinted at that in our intro, but I think I would not do this today. But the other career, which I thought was going to be my mainline career, was international law. And thankfully, I found another way. The other thing at the moment would always have been true, but even true now, is gourmet chef. So my personal creative outlet in my life and big enjoyment is I'm a big foodie on the eater side. And so therefore I have learned to be a foodie on the chef side. So I know, because my sister-in-law did this herself, but like, it's hard to work in a real restaurant. Like that's actual real work. Very, very hard and uncompromising, but just from a like enjoyment perspective, gourmet chef.
Do you ever see yourself not being an architect anymore?
Yes and no. I mean, I think I will not ever stop trying to frame things in a different and hopefully natural and hopefully elegant way. So from that perspective, I can't turn, that's a core part of me. I can't turn that off. Is it possible that someday I will, you know what? No, I don't think I ever will, to be honest. Like, even if I shift into, as many of my friends have done so far these days, shift into more like an advisory mode with various companies and individual people, coaching or whatever, which I love and kind of do as a side gig as well. I will never shy away from talking about the architecture stuff, if that makes any sense. So yeah, I guess I'll never stop.
When a project is done, what do you like to hear from the clients or your team?
Yeah. I mean, first and foremost, why do we even do any of these things? It's because it solved a real problem. So first and foremost, I want to hear, we had a problem or we had an opportunity and we solved the problem, or we executed on that opportunity. So that's number one. Like, at the end of the day, if we don't make things better, we should do something else. We can make something else better because there's lots of opportunities for improving. The other, though, for me is if I hear back, wow, that was really elegant how we approached that problem. That was really extensible. Like, other engineer, not Randy, can now see how we can evolve the system in this way and that way and the other way. So I guess that's the other thing that I would really want to see. And this is pretty from the team. It's like, oh man, we approach this problem in a way that opens more doors than it closes.
I like that.
Yeah.
Well, I know there are more topics we could talk about. I had some, as we talked, there were ideas that came into my head. We could go down this path. But thank you very much for being on the podcast. You're a great guest, and I hope we can do it again sometime.
Yeah, me too. I mean, look, between us, we have many decades, many decades of experience, and just being able to share some of those ideas together is great. So thanks for having me on. Happy to do it again. Loved it.